Good morning. My name is Dinesh Kumar. Today I'm going to talk about the subject power electronics and drives. It's on the subject code 15 MC 406 power electronics. So, what is power electronics? So, usually you would have heard about the term electronics. So, what is the difference between electronics and power electronics? So, as electronics, we would have heard about our cell phones, um, televisions, video games. So these are some of the electronic components which we have been dealing with our day-to-day life. So what is the term power that comes before it? So power electronics is something that deals with high voltage devices. So what does it mean? Usually electronics would have, mostly it might deal with like 12 volts, either it will be DC or 5 volts and DC. But whereas power electronics would deal with mostly voltages of 240 volts AC or DC, 440 volts AC or DC. So power electronics usually talks about high voltage devices. Okay. So why do we need power electronics and where do we use these power electronic devices? So this subject is going to talk about power electronics and drives. Okay. So as we know now, we have a difference between what is electronics that we have been using in our day-to-day life and what is the difference between power electronics and what is the voltage difference mostly we might be dealing with. Okay. So where it is used? So where is these power electronic devices used? Say for example, at home you have a switch. This is at home. Okay. You have a switch, you have a regulator and a fan. So when I turn on the switch, it will go through a regulator and it will turn on the fan. What is the purpose of this regulator? Why do we need a regulator to control the fan movement? So what does it do? Mostly the regulator is a speed control for the fan. Okay. So we use a regulator, mostly we turn the knob, it will increase the speed of the fan. If I turn the knob the other way, it might decrease the speed of the fan. So using this, I control that particular speed of the fan. This is for a house or commercial purposes. Okay. So whereas when it comes to an industry, especially anything, it may be any kind of industry, I would have say for example a bottling plant, like you might have had some sort of drink, like cool drinks. So one of those plants that has bottles that can go around and it will pour on that cool, like soft drinks in it, and then it will pack those particular materials. So say for example, this is a particular bottle. So usually they will send it through a conveyor. Okay, this, let's assume this is a conveyor. Okay, this is a conveyor stand. So say for example, this is like a filling station. Okay, so this thing will pour some liquid in it. So the bottles will be moving in this direction. Usually it will be like hundreds of bottles coming in one particular direction. So what will happen is when these bottles go in the flow and say that water is poured here, all right, or so whatever liquid is poured in here, this particular conveyor, this is called as a conveyor. This conveyor will help in controlling that particular bottle like motion of that particular bottle. So this is mostly comes in the topic of motion control. So conveyor, usually they will have like a motor connected to the shaft, a motor that will be connected to the shaft. So this particular motor, the speed will be varied. This motor is almost similar to a fan that we use at a house. It might be an induction motor. There are different types of motors that comes into picture. It might be a AC motor, it might be a DC motor, it might be a induction motor, it might be a servo motor, or it might be a DC motor that is like a series or a shunt. Depends upon the application. It can be any type of motor. So what I have to do in an industry, I would usually have a motor, and I have to control the speed and the position of that particular motor. So how do I do it? So you can say I can use some sort of regulator over here. This is for an industry, okay? So you can say that I can use some sort of regulator. Okay. In industry, if you go and check out industry, there is not just one motor or fan. Even if you look at a big building in some sort of auditorium, there are many fans over there. So if each and every fan speed has to be controlled, someone has to go manually and control this fan, each and every fan speed. So likewise, in an industry, there will be like hundreds of motors over there. So if I want to control the speeds, and another thing is this particular speed, for example, I have motor 1 here, I have motor 2 here, I have motor 3 here. So each motor will run at different speeds, and they will be in like sync with each other so that they get some automation process done. This is called as automation. Okay, so mostly it will be automated where no human will be present to control that speed, no human to control speed. So in that case, how will I get it done? So I have it's like turning the regulator, but you might not be there to turn the regulator. So how will I get it done? So this is where we use something called power electronics. Okay, so we will be looking in this in detail of these things in this particular chapter. I'll just give you an introduction of how these things work. For today's class, we'll look into some of the basic introduction, how it works. And then from next class, we'll go as per the units one by one. Okay, I'll give you an overview of how all these units are assembled. And then from next class, we will be looking into one by one all these topics. Okay, so the general assembly of power electronic system. This is just for your understanding, okay? A general understanding assembly of a power electronic system, okay? So usually there will be a source. Either it can be an alternating current or it can be a direct current. I hope you go ahead and study about alternating current and direct current. Usually alternating current is something like, you know these things. I'm just giving you a recap. It's a sine wave. Okay, this is an AC current, whereas a DC current will not be fluctuating. This is DC. Okay, there will not be a fluctuation. So this particular voltage source, this is called as a source. Okay, input. So this particular source usually will be connected to a device called a converter, a power converter. So this power converter will, maybe the input might be an AC supply, I might have to convert it to DC, or the input might be a DC supply, I might have to convert it to AC. There are names for these things. We call it as a converters, choppers. It might be either it might be a DC, I might have to convert it to DC. Okay, or AC to AC. It might be anything. So there are names for these things like rectifier, inverter, choppers. As we go by, we'll look into in detail of all these things. So AC to DC, DC to AC, AC to AC. So we call it as inverters, choppers, like cycloconverters. So we use all these things, rectifiers, so that we control that input power supply. So usually, as I said, we deal with either 240 volts or 440 volts power supply. So 240 volts is like usually a single phase supply. This is like a three phase supply. Okay, so that means it's an industrial setup. It's not, these things is not used where you see in house or in commercial application. These things are used in industries. All right, so when these things, okay, power electronics devices, I converted it so that I control the power supply that goes into that particular motor. It can then, this is supplied to a load. So what is a load? What type of load it might be? It can be motors, either it can be like DC or AC motors, or it can be anything, FPGAs, microcontrollers. These are all some of the applications. Okay, these are some of the end devices. Mostly in an automation industry, it will be used in motors majority, or it might be sent through a microcontroller, and a microcontroller will be connected to a motor. So this is a setup how it has been used in general as a power electronic systems. So as I said, why do I need it? I have to control these output. So what is the difference? Why do I have to control it? It's a simple thing. When I turn on the fan, say it's a cold climate in winter, and the fan runs at a heavy speed, how will you feel? You will feel cold. So what will do? I'll turn down the speed so that I don't feel too cold. The same like in the industry, say it's a bottling plant, or say it's a packaging industry, or say it's a transporting place or something. Say I'm carrying 100 kg or 10 kg material on some sort of trolley, and it's running at a speed of 120 kilometers per hour or something. All of a sudden, if I stop it, that package will slip away. So I have to control that package being transported in a controlled fashion. So everything comes into controlling of the motion of a particular load, or it can be an end application. So the main objective for this particular class for us is, our objective is to first understand all the power semiconductor devices. What are all the types of power semiconductor devices? And second, the converters, like what are the various converters that comes along with this power controlling. And then third, the controlling part. How do we use 1 and 2 to control the loads? It can be anything, as I said, motors, microcontrollers, or FPGAs. It can be anything, etc. Okay. So our main idea is to study about the power conversions and what are the components that go into it. Okay. All right. So I'll briefly cover up some of the units, and I'll give you a little bit of difference between what is one particular component. Okay, usually unit 1, okay, for power electronic devices, as I said. So unit 1 consists of power diode and SCR stands for silicon controlled T-fire triac, power transistor, MOSFET, IGBT. So, according to your devices, these are power electronics devices, okay? So, as I said, I will usually do the power conversion. How will I do it? I use these power electronics devices, okay? So, these are all like solid state devices, okay? What does it mean, solid state? Solid state power electronic devices. That means I won't have any moving components. There won't be any moving components. It's all electronics, okay? So, the unit 2 usually deals with some of the basic converters and choppers. So mostly I'll be dealing with phase control, single phase, three phase. So you should be familiar with the terms single phase supply, three phase supply, and then how do I do the phase control, how do I do a single phase control and then three phase control. And there is another thing, there are something like controlled and like I'll convert an AC supply into a DC. So these are called as rectifiers. So how will I convert this three phase supply in a controlled fashion or in an uncontrolled fashion? And usually I'll give it to R, L load or resistive load or a resistive inductive load, and I'll see how my output works. This mostly these things on choppers and cycloconverters, these things will come into unit 2. And unit 3, mostly I'll be dealing with inverters and the techniques. So we might have heard about inverters, like UPS, uninterrupted power supply in our homes. Nowadays it's common everywhere in each and every home, and especially in India when there is a power power failure. Most of the houses has an UPS installed in their house. So what does the UPS do? They have a battery. When the AC supply is on, for example, I'll just draw over here UPS. So you'll have an input single phase supply. This means single phase, okay, one phase. I'll put it in a inverter box. So this will be connected to a battery. And then I'll be giving it to my loads. Loads means that you might have a fan, you might have a light. So what will happen is when I send in the supply, when there is a supply is on, usually it will just go through it and I'll send the load here. And at the same time, I'll charge the battery. Battery will be charged. But whereas it is off, battery will supply the signal, supply to the load. Okay, it will go through the inverter. Okay, so what will happen over here? AC is converted to DC to the battery, and when the supply is off, DC supply is converted to AC through an inverter. Okay, so this is how it does. So this is something we deal with in the third unit. And unit 4, mostly it will be like solid state DC drives. So we'll be dealing with how to control DC motors, some of their applications like control system, speed control of DC motors. So we'll be dealing with it. And then unit 5, we'll be dealing with solid state AC drives. So we'll talk about how to control the speed of an AC motor, and how do I control the speed, and how I change the speed so that I can get some of the applications. So this is like an overall picture of what we study about, and there are few experiments. Since this particular subject is a lab component, hopefully I will see how we get the experiments and I'll post it for you. So mostly we'll use a single phase and three-phase controlled and uncontrolled rectifier for R and RL load. So this will be one of your main experiments. So we'll be like dealing with all these things. So we'll study about what it's mean by control, what it's mean by uncontrolled. So these are some of the overall, this gives, since it's an introduction class, I'm giving you an overall picture. So just give you a recap. Power electronics and drives. Okay, the subject code is 15MC406, power electronics and drives. Power electronics deals with high voltage devices. So usually we would have talked about electronics. So this doesn't work here. Electronics is something that we use: cell phones, televisions, video games, watch, whatever it is. Usually their operating voltage will be like 12 volt or it will be 5 volt. It's less than that. But whereas power electronics will be using like 240 volts DC or AC, 440 volts DC or AC, single phase or three phase supply. Okay. So where it is used? Usually in industries. Okay. Mostly in industries. So for example, at home, we have a switch, we have a fan, I have a regulator. Usually I control the speed of the fan through a regulator. So why do we need to control the speed? Maybe we just feel cold or it is too hot, so we need to increase the speed. But whereas in industry, some applications, usually we can't control the speed of the motor. The fan has a motor in it, it's an induction motor. Even in industry, we use some induction motors, depends upon the application. We use servo motors, synchronous, there are different types of motors. So in industry, usually motors will be used, and especially for an automation industry, this is where it comes to picture. Why we need it? It is mostly used in the term automation. So in an automation industry where there are less human intervention and there are too many motors and it has to be controlled and it has to work in a synchronized fashion, we use these power electronic components. So as I said, mostly this motor has to be controlled for speed and position, and this is where power electronics comes into picture. So the general assembly, then I just gave you an overall picture. These are all just introduction how it works. The general assembly is usually I have a source, mostly it will be an AC supply or a DC supply, and then it will be a single phase supply or a three phase supply. I'll have a power converter. Mostly I'll convert that AC supply into a DC supply so that I can give it to a DC motor, or I'll convert that AC supply into another AC supply that's called as variable frequency drive. I'll just change the frequency and then use it for that speed control of that particular motor so that I can control the speed and position. And then DC to DC, sometimes there might be some high voltage DC, say that 630 volts might be converted into 220 volts DC. Based on the applications, I'll use it for some motors, DC motors. So the main objective, as I said, the main objective of this particular subject is to know about what are the power semiconductor devices that's been used in the industries. There are many, that's a huge family. So we'll be focusing on, I'll tell you next what is it focused on, and then various converters that we use for converting AC to DC, DC to AC, DC to DC. So how does these converters work using these power electronic devices? All right, and then how do we use it to control the loads? Say for example, motors mostly will be using DC and AC motors. All right, for this syllabus we will be using these things. So as I said, our first unit mostly deals with power diode, silicon control rectifier, triac, power transistor, MOSFET, metal oxide. MOSFET stands for metal oxide field effect transistor, IGBT, insulated gate bipolar transistor. All right. So solid state power electronic devices, these are the things that we will be studying in our first unit. We'll be studying about how they are constructed, how they are joined together, how they are how do they conduct electricity when I supply electrical supply on it. So then how do they conduct? So that's one thing we'll do. And then converters and choppers. So once I know how these things work, the next thing we'll be dealing with how I use one of the devices to do a conversion application, chopping application, inversion application. That will be covered in the third unit. And then once I get this thing, using these, how will I convert a DC supply, a DC motor and an AC motor? So this is what we'll be dealing with. I gave you an example of how an inverter works and some of the experiments that we'll be dealing with in this class. So this gives an overview of all the topics. Before we, for the next class, we'll be looking into power diode. All right. So the first topic will be like power diode. Before I go into power diode, probably I'll do a recap next class. But we have to understand diode first. Before that, we have to understand P-N junction. So what is meant by P-type and N-type? So you can take this as a homework, but at the same time, I'll give you an explanation over here. You can also study yourself of what is meant by P-type and N-type. You might have studied in your high school physics of what does it mean by P-type. So usually, this is like a semiconductor device. You might have seen it in a very small, something like that. It'll be like, it's not even this big as I seen in this diagram. That's a diode, mostly a diode or something, a LED. You might have seen an LED which is really small. Even in your cell phone, there are some LEDs like that is really, really small, which shows when it is charged or discharged or when its battery is low, something like that. So, usually they use germanium or silicon. These are like materials. Mostly silicon is obtained from sand. If you go through desert or sea or like nearby beach, the sand that we get there, that's all silicon. What they do is they'll get that sand, they'll heat it up, okay, and once they heat it up, they'll get a particular silicon layer out of it. So usually P-type is mostly deals with like assuming it's positive. I mean, like by default they'll call it as positive, and N-type is negative. Okay. So, say for example, silicon usually have 4 electrons. Alright. So, mostly silicon will be on the purest form, it will not be a very good semiconductor. So, what does it mean semiconductor? Semiconductor is something that can conduct electricity on certain conditions. So, what they'll do is they will do something called doping, that means adding impurities. Okay. So this doping process is by adding impurities. What they will do is, usually they'll use boron or phosphorus. So by adding this, either this will become positive or this will become negative. It will add an electron to it. It will add a hole in it. Alright. So this will become P-type and this will become N-type. Alright. So I would like you to look into it. Probably the next class I'll look into how this P-type is made in detail, how this N-type is made, and then what they will do is they will merge this P and N. So this is called as a diode. This P and N is called as a diode. Okay, this is as it is. This thing is an electronic device. It's not a power electronics device. So I'll tell you how this, unless otherwise you understand how this power electronic devices work. Probably we can move on to the next topic called how a power electronic device is used. So I'll probably use this thing and then I'll explain how the power electronic device is used. So what they will do is they'll supply positive supply here and the negative supply here. So on certain conditions, the supply will turn on and turn off. This is a power electronic. This is an electronic component. So once it is joined, this is called as a depletion layer, and there is a process called depletion, diffusion. So take it as an homework. So I'll give you the topics: diffusion, depletion. So study about all these things. So unless you understand all these things, it will be hard for you. You understand how this P and this is the basics. How this P-N junction works. How this P-type, N-type, the doping. Depletion, diffusion, all these things, how it works. Once you understand all these things, it will be easy for us to derive all the other semiconductor devices, like silicon conductor rectifier, triac, power transistor, MOSFET, IGBT. So if they play around with this P-type and N-type material just by adding a little bit of impurities or having less impurities. So that's it for today's class. So probably from next class on, we will start by looking into power diode and its characteristics, construction, working and everything. Thank you.